My name is Gabriel. I work at iFood. We're a Brazilian food delivery tech company, and I'm your build guy there, you might say. I work in the mobile platform team. We're a small DX initiative aimed at our mobile app developers. And my goal here is to show you how easy it is to get started with the Gradle Enterprise API and leave you with some ideas and tools to take home. This is a little more on the practical side. And if you were here for ATN's talk and seeing how you can extract Gradle Enterprise data, this is more so that you can do that before you extract the data in that way. So Gradle Enterprise gives you plenty to work with from the start. It will collect a lot of useful data from our builds and aggregate it into useful metrics and graphs. Most of that data is available in the API so that you can automate something with the data. And not a problem there. And expand on top of what Gradle Enterprise already offers. And this talk is about the newer REST API, by the way. If you've seen the previous one, it's simpler to use. But moving on, a few ideas for starters. You could, for example, build a weekly job that runs a benchmark of your build and compares build time and test time and really anything that's in a build scan. You can compare it across time automatically, so you don't have to burden a developer to do that. You could build all sorts of monitoring. For example, monitor whenever a new flaky test appears. That is a test that sometimes passes and sometimes fails. You could create a ticket for it automatically and assign it to the owning team if you can detect that. It's really useful too for investigations. So when you're dealing with a build issue that you want to root cause, the API can help you search in new ways and, for example, create graphs and metrics to answer questions that you currently can't with the enterprise dashboards. I'll focus on these two because they'll let me showcase some nice tools. So the first tool is a little library that we built to help work with the API in Kotlin. And we chose Kotlin because it's a versatile language and what most of our mobile developers are comfortable with. So they have no language barrier in contributing to our team's projects. One of the examples that I'll show is actually an external contribution from a developer outside our team, thanks to this. So the library is on GitHub, and it's actually mostly generated code from the official OpenAPI spec published by Gradle. It has some common utilities too, so that you don't have to copy paging logic and joining logic across projects. And most importantly, it's easy to add. So you don't even have to be in a full Gradle project and set up and maintain this code generation as the official sample suggests. You can just include this dependency in a project or a quick Kotlin script or a Jupyter notebook, as I'll show later on. And this is a great way to get started with the API because you just need the URL, a token, and just create a simple script with it. So you first instantiate a client, very simple, and it has the APIs organized just like in Gradle's online docs. And again, this is generated, so it has even the Java doc, exactly the same as the online API manual. So you get autocomplete and everything. And the first example that I want to show with this is for monitoring. How to automate flaky test tickets. So the current situation that we have, as I said, flaky tests sometimes pass and sometimes fail, and Gradle Enterprise can already detect that and show you statistics of how many you have. But someone has to proactively go in there in the dashboards and create tickets so that the teams can know about it or send a Slack message somewhere. and we can lift that burden and automate this work, create the tickets automatically, and maybe even create insights of how much time this is wasting in CI, for example. So we'll use the tests API, which is in beta. It has the get test containers endpoint, which will basically list the flaky tests. The name doesn't matter much here, but it's about test distribution. We just have to pass the period that we want, so the start time and the end time, and say that we want only the flaky tests. So all the flaky tests from the past day. And this would give a response something like this. All of the tests that were flaky, and the name and the flaky count of them, for example. And this is really all that you need to get started using the API. These two lines and a simple dependency, and you can build a lot with this. From here, you can integrate with your issue tracker and build all sorts of logics, such as inferring which team owns that test and sending a message or something. So this is basic monitoring done very cheaply. The next tool would be Jupyter Notebooks before I show the last example. So notebooks are this tool for data analysis that are usually used with Python, but support Kotlin and many others. And JetBrains does the Kotlin support. It will really help us to iterate on the data faster when we're working on monitoring code like this. So the first benefit would be that we can rerun a single line of code, for example. A simple example, we'll fetch some builds, filter which one of them have one error, and print them. This is usually a single execution unit, so when you want to change how you're printing, you have to rerun everything. That can waste a lot of time, even with the caching that the library actually does for you. With Jupyter Notebooks, you can split them, split this code into pieces, and when you want to change how you're printing, you'll just change the last cell and rerun that. So this is really helpful when building automations like this. Number two is very easy to add libraries like ours. You'll have autocomplete here, so you don't even have to know the coordinates for the libraries. You can just create a notebook and add our library like this. So it's very simple. And number three is data rendering. It has rich output in each of these code cells. So it will render an HTML or an image that you have in the last line there. But this really shines when you combine it with the libraries. So libraries can teach it new formats to render. And DataFrame, for example, is a library for tables from JetBrains. And with this library, we can very easily turn a list of builds into a table and visualize the data that we have there, rendered right under our code. And another one would be graphs. You can build your own graphs very easily with this. Candy is a library also from JetBrains to build graphs, and it will all be rendered right there under our code. So last but not least, you'll be able to wrap all this up, code and graphs, into documentation and use it to document how you approach the investigation. And moving on to an investigation example, finding remote cache errors, which is something that Etienne mentioned if you were here in the previous talk. So these are basically, whenever you have remote cache enabled, Gradle will ask the remote cache if there's cache available for one task by making HTTP requests. When one of these requests fails, it will disable the build cache for the rest of the build. The problem here is, that behavior is okay, it should be disabled, but how you find these cases is kind of hard today. So you will see this warning in a single build scan, but it's hard to find this case alone, so you have to stumble upon it and see the warning. And you'll have to get lucky twice to find other cases, because there's no way to search Gradle Enterprise for builds that are suffering from this problem. And you can't see also the rate at which is occurring. So the API can not only help us quickly find other cases, but root cause the problem, and also you can build alerts with this if you want, like a gentleman asked previously. So we'll use the builds API this time, and there's the get builds endpoint. It will give us all the IDs of builds since a start time, and this actually requires paging, but as I mentioned, the library has a few utilities for this, so you don't have to implement it. Just use this extension function and you'll get a stream that does the paging behind the scenes. We'll call another endpoint with these IDs to get the build cache details. And with these build cache, in these build cache details, we have whether the remote cache was disabled due to an error, which is the information that we want. That results in that warning on the website, but now we can use it to find other cases. And just with this fairly simple code, we can already find other cases. But going further with Jupyter Notebooks, we can, for example, turn this into a table and see very quickly that all our cases here are CI. You can see on the tags column, they all are CI builds. And this is another clue that you quickly found. And you can turn this into a CSV and send it to your infrastructure team and say, ask if there were any incidents that you don't know around these times, for example. And you can very quickly build a graph out of this to see other patterns and find other clues. For example, get the dates. And as I showed, a clue here would be that most of your cases are on Mondays. So again, this is a suite of tools to help you root cause things and investigate build issues. So I hope this inspired you to build something with the API. Again, a little more on the practical side. If you're not doing any of the Athena and S3 setup that was mentioned in the previous talk, this is a great way to get started and quickly automate something. This QR code and the link point to a gist with links of everything I mentioned, including the library. Thank you.